We operate under this illusion of precision when it comes to the global economy.
Oh, absolutely.
Like you look at an item online, you see the price tag, you hit buy, and boom, the transaction is just complete. The money leaves your account, and you sort of assume the global supply chain will just, seamlessly mobilize to make that product appear on your doorstep.
Right. We treat the economy like a vending machine.
Exactly.
Yeah.
Put the currency in, you get the product out.
Yeah, and we rely on that binary logic because, honestly, it makes the immense complexity of global trade feel manageable. I mean, we want to believe that price is the ultimate objective measure of value.
Right. If something is expensive, it's scarce. If it's cheap, it's abundant.
Exactly. The price tag is supposed to be the entire story.
Well, I was looking through this stack of analytical memos and raw news reports slated for tomorrow, April 30, 2026. And for today's deep dive, we're really getting into how that vending machine logic is completely shattering.
It really is. It's falling apart.
Yeah. We are not looking at a world governed by price tags anymore. We're tracking this massive, quiet, structural transition where the traditional metrics of cost and capital are just, well, they're failing to explain what's actually happening on the ground.
The foundational architecture of the global operating system is shifting. The sources we have point to a profound recalculation happening right now.
Yeah.
We are moving away from a traditional price market and entering what we can, define as a connectivity
A
market.
connectivity market.
Right. The primary determinant of value is no longer just the dollar cost of an asset or a piece of land or a barrel of oil. The determining factor is whether that asset can successfully plug into the necessary physical infrastructure, like power grids, water tables, and secure logistical corridors.
So if it can't physically connect, the financial price just becomes completely irrelevant.
Exactly.
I was reading a framework in these memos that uses a physics concept to describe this transition, and they call it shear. Normally, I hear that term in aviation, right? Like wind shear tearing at an airplane wing because of two opposing currents of air. But here, they are applying it to macroeconomics.
And it translates perfectly to what we are seeing across the globe. Shear, in this context, is the immense friction generated when incredibly fast systems collide with very slow systems.
Yeah, so give me an example of a fast system.
High-speed systems are things like capital investment, digital algorithms, the deployment of artificial intelligence software. Those operate near the speed of light. They scale instantly.
Right.
But they are entirely dependent on low-speed systems, pouring concrete, trenching transmission lines, securing water permits, and moving physical freight across oceans.
So the high-speed digital operating system is basically trying to drag along a low-speed physical reality.
Precisely. And that friction, that shear, is starting to tear at the supply chains.
Well, I want to look at how this shear is manifesting at the most critical physical bottlenecks of global trade, because the reports coming out of the Hormuz Strait right now are incredibly tense.
Yeah, the situation there is a perfect example.
Total Energies is essentially halting the restart of their Middle East production until the passage is physically stabilized, like tankers are just anchored and waiting.
Right.
And it's not just the corporate giants either. Humanitarian aid agencies are publicly demanding secured corridors just to move basic supplies because of the transport delays and fuel bottlenecks.
Now, a traditional economic analysis would frame this simply as a supply shock.
Right, like gas is just going to cost more.
Exactly. The assumption is that increased geopolitical risk in a major transit choke point just raises the cost of doing business, which then translates into a higher price per barrel of oil.
But that misses the point.
It completely misses the structural shift. We are observing the emergence of a probability market.
Probability market. I want to break down how that actually works in practice, because I was thinking about this from the perspective of like a maritime insurance underwriter.
Oh, that's a great angle.
Right. An underwriter calculates premiums based on historical data and predictable risk models. But when you have a corridor that might close unpredictably or ships that might be actively targeted, the risk is no longer a calculable percentage.
No, it becomes an unquantifiable unknown.
Exactly.
And when risk becomes unquantifiable, the insurance market doesn't just raise prices, it withdraws coverage entirely.
Wow.
And without insurance, a vessel legally cannot enter most major ports.
So it's like the physical cargo might exist, the buyer might have the funds ready, but the transaction just dies.
Yep. The market is pricing the probability that the cargo can physically transit the strait, maintain its insurance underwriting, and actually reach the destination.
So it's as if we've stopped paying for the actual commodity. Like the oil itself is secondary.
Right.
The buyer is paying a massive premium for the probability that the physical logistical corridor hasn't collapsed. So you could have $1 billion sitting in a bank account, but if the shipping lane is closed, your money cannot magically teleport the oil to your refinery.
Exactly. The value has migrated from the product to the transit membrane itself. A price market guarantees delivery based on purchasing power. But a connectivity market reduces global operations to a logistical gamble.
Where physical friction just overrides financial capital.
That's it.
It's fascinating because we tend to think of physical transit bottlenecks as a legacy industry problem.
Yeah.
You know, oil tankers and cargo ships are heavy, slow, and bound by geography.
Sure.
But the memos explicitly connect this physical logistical crisis right over to the digital logistics of the AI boom.
Yeah, they do.
We assume the digital world is immune to physical constraints. I mean, we call it the cloud, which implies something, ethereal and weightless.
But the reality of the cloud is millions of incredibly heavy, power-hungry metal boxes bolted to the ground.
Right.
They require massive industrial life support systems. I mean, AI data centers represent the ultimate high-speed capital system. The investment rounds are raised in weeks, and the software scales globally in days.
Yeah, it's insane how fast it moves.
Yeah. But those algorithms cannot execute without an uninterrupted, massive flow of electricity.
And this is where the software force hits the immovable physical grid.
Yeah.
I was looking at the data on PJM interconnection. For anyone listening who isn't familiar, PJM is a regional transmission organization that coordinates the movement of wholesale electricity across, I think, 13 states in the U.S.
Yeah, they cover a huge area.
The memos detail how PJM is being forced to completely overhaul how it processes new power project queues. Like, they are simply overwhelmed by the tidal wave of requests from AI data centers wanting to plug into the grid.
Well, we have to understand the mechanics of a power queue to see why the shear is so violent here. When an industrial facility wants to connect to the grid, they don't just flip a switch.
Right.
The grid operator has to conduct a system impact study. They have to ensure that adding this massive new load won't exceed the thermal limits of the existing transmission wires.
Yeah.
Or, destabilize the voltage for the entire region.
And those studies take a while, right?
Those studies and the subsequent physical upgrades to substations and transformers, they take years.
Years. While the AI companies are operating on product cycles measured in months.
Exactly.
The sheer scale of the power demand is difficult to comprehend. The memos highlight Greater Houston, where CenterPoint Energy is currently facing a staggering 12-gigawatt industrial load request.
That number is just wild.
Right. And it's driven almost entirely by new data center proposals. They're scrambling just to get 8 gigawatts connected by 2029. And to put 12 gigawatts into perspective for you, 1 gigawatt is roughly enough to power 750,000 homes.
Wow.
We are talking about standing up the power equivalent of multiple major metropolitan areas solely to keep servers running.
See, the digital realm may appear infinitely scalable, but the physical layer required to host it is rigidly finite. You cannot write a line of code to generate more raw electricity.
Right.
You have to secure land, navigate local zoning, acquire transformers that currently have multi-year backlogs, and physically lay high-voltage cable.
So, if the capacity to move electrons is the ultimate bottleneck, that completely upends how we value geography.
It really does.
Because in traditional commercial real estate, valuation is driven by proximity. You want to be near a financial district, a major transit hub, or a population center. But now, the map is being redrawn based entirely on physical grid access.
Yeah, the concept emerging from this transition is powered land.
Powered lands.
Right. The inherent value of a parcel of real estate is no longer derived from its location on a map, but from the connectivity rights embedded in that dirt. The sources highlight a fascinating case study involving an old, abandoned, heavy industry site near Middlesbrough in the UK.
Normally, a decommissioned industrial site is a total liability. It requires environmental remediation, it's an eyesore, and it's, far from prime commercial development.
Yeah.
But suddenly, this exact site is the target for a massive AI data center.
Because of the legacy of that heavy industry left behind the exact infrastructure that digital capital is desperate for, the site already has high-capacity transmission lines trenched into the ground.
Oh, wow. So the hard part is already done.
Exactly.
Yeah.
It already has industrial-scale substations. It has pre-existing permits and physical access for deep-water cooling. The digital economy is basically cannibalizing the footprint of the old industrial economy because the physical connections are already built.
So real estate's golden rule of location, location, location has really just become connection, connection, connection.
That's a great way to put it.
And we are seeing the design of these facilities just warp around these physical constraints. Like, look at the situation in southern New Mexico with Project Jupiter.
Oh, right. The one linked to OpenAI and Oracle.
Yeah, exactly. The reports link it to massive tech players.
Yeah.
And they're attempting to build an AI cluster in an arid environment. So they're being forced to completely rethink their engineering.
Well, they have to. Data centers generate an immense amount of heat. Traditional air conditioning is insufficient, so they rely on evaporative cooling systems.
Which use a ton of water.
Right. Millions of gallons of water a day, physically evaporated to draw the heat away from the servers. In a desert environment, that kind of water draw is physically and politically impossible.
So what do?
Project Jupiter is having to redesign their operations for closed-loop cooling and reduced air impacts. They are absorbing massive financial costs just to conform to the local physical realities.
It totally changes the dynamic between these tech giants and the municipalities hosting them. I was struck by the report out of Gliwice, Poland.
Yeah, the municipal data center.
Right. The municipal government there just approved a plan to build and operate its own city data center. Like, they aren't waiting for a private company to come in and negotiate utility rates. They are internalizing the infrastructure as a core municipal function.
This represents a massive phase shift in how we understand civic administration. Cities are transitioning from passive geographical boundaries into complex urban operating platform. Right. In an urban operating platform, you have the human OS housing, public transit, sanitation competing directly with the Power OS and the emerging AI OS.
And they are all drawing from the exact same physical motherboard.
Exactly.
I think about how an operating system on a computer actually crashes. It happens when two different programs try to allocate the same limited resource-like memory at the exact same time.
Yep, the system locks up.
So if a city is an operating system, and you have an AI data center and a residential neighborhood, both calling upon the same water reservoir or the same electrical substation during a heat wave, you get a physical system crash.
You get rolling blackouts, you get water rationing. You also see aggressive economic displacement.
What do you mean by displacement in this context?
Well, if an AI facility secures the local power capacity, new housing developments can't be built because they can't get grid connections, which immediately spikes the cost of existing housing.
Ah, I see.
The physical infrastructure becomes the hard-coded limitation of the local economy. A failure to synchronize these systems results in severe local political backlash.
Which makes sense.
Yeah.
But, to even build these powered cities or upgrade the grid or manufacture the servers required for the AIOS, we have to talk about raw hardware.
We do.
We need advanced batteries, copper wiring, and semiconductors. And sourcing the materials for that hardware pulls us right back into the brutal friction of physical logistics and resource extraction.
The transition to electric vehicles, artificial intelligence, and renewable energy grids requires an unprecedented extraction of rare earth elements and conductive metals.
Right.
And the pursuit of these materials is colliding directly with the most vital and inflexible constraint on the planet: water.
The sources outline two distinct geopolitical events that perfectly capture this tension. In the Democratic Republic of Congo, we're seeing the establishment of a $100 million U.S.-backed mine security force.
Yeah, that's a huge development.
And the explicit mandate of this force is to physically protect the supply lines for copper, cobalt, and coltan.
Coltan is a prime example of a critical bottleneck. It's short for columbite tantalite.
Right.
When refined, it yields tantalum, which is a highly heat-resistant metal capable of holding a high electrical charge. It is absolutely essential for manufacturing the capacitors inside our servers and smartphones.
So we literally can't build the cloud without it.
Without tantalum, the density of modern computing hardware would literally melt itself down.
Wow. So we are dispatching paramilitary security forces to ensure the physical transit of the materials required to build the digital cloud.
We are.
And while that security dynamic plays out in Africa, a completely different environmental friction is escalating in South America. The lower house in Argentina is advancing legislation to ease mining regulations near glaciers and paraglacial areas.
Yeah, that was a controversial memo.
Very. They are intentionally loosening environmental protections to boost the extraction of copper and lithium to feed global demand.
See, lithium extraction, particularly from brine, is an incredibly water-intensive process.
Right, because of the evaporation pools.
Exactly. It relies on pumping mineral-rich water to the surface and allowing it to evaporate in massive pools, which heavily depletes the local water table. Doing this in high altitude, arid environments directly threatens the glacial water reserves that local communities and ecosystems rely on.
It presents a massive paradox for the global transition. We heavily focus on reducing our carbon footprint by moving away from fossil fuels and towards EVs and digital efficiency.
Right.
But the physical mechanics of that transition, mining lithium for the batteries and utilizing millions of gallons of water to cool the servers processing the AI, it suggests we are inadvertently trading a global carbon footprint for massive localized water footprints.
It really does.
It seems like water is the hidden, unyielding boundary where all of this structural tension is accumulating.
That's because water operates outside of traditional economic theory.
How so?
Well, you can inject liquidity into a market to fund an AI startup, and you can leverage debt to build a factory. But you cannot print more water to cool the servers or to replace an evaporated glacial reserve.
No, you can't.
When the high-speed demands of capital expansion crash into the absolute low-speed reality of a depleted aquifer, the system breaks.
So we are witnessing a reversion in how the world handles crucial resources. For decades, we operated on a market logic, right? Whoever pays the highest price secures the commodity. But the reports from the Congo and Argentina suggest a rapid return to a raw security logic. Value is shifting to the entity that can physically protect the extraction site, physically transport the material through contested corridors, and secure the massive water rights necessary to process it.
The high-speed technologies designed to propel us into the future are slamming violently into the most ancient physical realities of the Earth. The systems of global trade, urban planning, and resource extraction are being forcibly integrated.
And bringing this back to you, listening to this deep dive, it's vital to recognize how these massive structural shifts bleed into everyday life. When price alone no longer dictates how the world operates, the symptoms show up in seemingly disconnected ways.
Exactly.
You might see an unexplained spike in your local utility bill, or read about a controversial new zoning law being debated at your city council regarding industrial water rights.
Or you might experience bizarre cascading delays on shipping packages that seem to defy explanation.
Right. The underlying cause isn't just a localized glitch. It is this profound recalculation of connectivity. Fast capital systems, the algorithms trading on Wall Street, the rapid expansion of AI models, the push for electrification, they are officially colliding with slow physical systems. The capacity of the power lines running down your street, the depth of the water table beneath your county, and the physical security of a shipping lane thousands of miles away are the new boundaries of our economy.
I think the most precise synthesis of these reports is that AI, resources, cities, and logistics may no longer be moving separately, but are beginning to reorganize through a single membrane called connectivity.
Reorganizing through a single membrane. It really forces you to view global events not as isolated crises, but as pressure points in one massive structural transition.
It's a completely new paradigm.
Which leaves a complex question to consider as we watch this new operating system boot up. We built the modern world on the assumption that capital could overcome any physical barrier. But if direct connectivity to power, to water, and to secure physical logistics is the new unyielding measure of value. Let me restart that. If connectivity is the new measure of value, what happens to the communities, the industries, or even the nations that find themselves unable to plug in? In a decade, could the ultimate luxury simply be an unthrottled connection to physical reality?
That's the real question.
Thanks for joining us on this deep dive. Keep questioning the structures around you.